All right, welcome back. The last thing we're going to look at is horizontal and vertical flips. Okay, and those don't have any crazy things. Those are just going to be, so f of x, when we change to f of negative x, that's a flip across the y-axis. Okay, or a horizontal flip. F of x to negative f of x, that's a flip across the x-axis. Or a vertical flip. Okay, let's do a couple examples of just putting it all together. Well, let's do a couple examples first with just the flips, just to sort of see how it works. So let's take y equals the square root of x. Okay, y equals the square root of x is a great example for these flips. If I could draw perpendicular lines, that would be awesome. Okay, so now y equals square root of x looks like so. Okay, now a horizontal flip, y equals square root of negative x. Well, that one actually kind of makes sense. That's why it's the example I chose. Because what is the domain here? Negative x should be bigger than or equal to 0, or x should be less than or equal to 0. So in this case, when we take y equals the square root of negative x, the graph's going to actually look like so. Okay, versus, let's say, y equals negative square root of x. Which looks like so. Okay, that's a flip. That's a... Let me move this so that the words don't get caught up. So this was a horizontal flip. And here we had a vertical flip. Let's move this over to there. There. Okay. All right. Let's put all of this together. Okay. So when you do these problems, okay, you're going to be given an equation, and then you're going to have to graph it using the base function and a series of transformations. Okay. One of the things to keep in mind is that the order in which you do the transformations might matter. Okay, let's do an example where I'll show you why it does. So let's take y equals, let's say, 5 minus 3 x plus 4 squared. Okay, so start by graphing a coordinate axes. Okay, now what is our base function? Our base function is, of course, y equals x squared. Okay, now where is our vertex? Our vertex is whatever makes the thing we're squaring 0 and the point at which that occurs. So -4 is the x-coordinate, and 5 is the y-coordinate. Okay, now it's not asking us for that yet, but that's sort of giving us an idea of what to do. Now, when I think about the shifts or the transformations, go inside to outside. So the first transformation is going to be left by 4, or a horizontal shift of -4. Okay, so we're going to start out with, let's say we have y equals x squared, horizontal shift, 1, 2, 3, 4. Now, what's the next thing? We have this 3. Okay, so that 3 is happening. Is it happening on the inside of the base function or the outside? It's happening on the outside. So it is a vertical stretch by a magnitude of 3. Okay, so we're going to move this. So this is going to be, instead of having this point 1, 1, it'll be at this point, sorry, -3, 1, it'll be at -3, 3. So we've stretched it a little bit. Now, what's the next thing? We've got this negative sign. Okay, we've got this negative sign. So that is a vertical flip. Okay, vertical flip. So zeros or -4 zeros stays the same. But now, instead of having -3, 3, you're going to have -3, -3, -5, -3. Okay, now the +5. What does this +5 do? This +5 is a horizontal shift, I'm sorry, a vertical shift up 5. Okay. So that ends up being, the one in blue is our final graph. Okay. So make sure you do these in order. Specifically, if you do these out of order, you're going to get the wrong graph. Okay. Play around with it if you like and see what happens if you don't do those out of order. Okay. Yeah, you see what happened, right? Okay. All right, that's it for 1.5. I'll see you all in the 1.6 section next time.